number 5. So we are given that 5c plus 1 is equal to 2c minus 8. And we're trying to prove that c equals negative 3. So to set it, you've got your proof, you guys have your boxes, right? So we have statements and justifications. So the first one is always what? The given. So we have 5c plus 1 equals 2c minus 8. And so that's our given. Right, so then when we're solving this equation, we're trying to solve it for c. So we need to get everything with c on one side. So I'm going to subtract my 2c from both sides first. So then that's going to cancel out those. And then 5c minus 2c is 3c plus 1 equals negative 8. And how did I get from step 1 to step 2? Right, that's our subtraction property. All right, so then now I need to move my 1 over because I want to get c by itself. So I'm going to subtract 1 from both sides, which will give me 3c, right, those cancel out, equals negative 9. And what did I do there? I subtracted again. All right, and then what's my next step going to be? Division, right? I have to divide both sides by 3. So then that leaves me with c equals negative 3. And I got that because I used the division property. All right, so if you did it in like a different order, if you subtracted the 1 first, then the 2c, that's perfectly fine. Right, as long as you get to the same end goal and you write down the right properties, it's okay if you do it in a slightly different order. But that division is going to have to be last. Okay? All right, let's move on and do number 6. So we are given that, this is number 6. M is equal to n plus 5. And 2m is equal to n. And we're trying to prove that m is equal to negative 5. So we need to get an equation that just has the letter m in it. Right, so how can we do that? Right, so we can substitute this 2m in right here because it's equal to n. Right, so again, our first step is still our first 2 steps in this case would be our givens. All right, and then step 3, we're going to go ahead and do that substitution. So we'll have m equals 2m plus 5. All right, and then what do we do from here? Yep, what were we saying? We can't divide yet. Yeah, so we're taking the 2m over, so we're going to subtract it. Good job. So then that leaves us with a negative 1m on this side equal to 5. And so we subtracted.
Mine ended up being the opposite way.
That's okay.
Yeah, that's fine. I just wrote it.
Or subtracted, it should say subtraction.
Don't you just, like...
Yeah, and so then now we divide by negative 1. So So we get m equals negative 5.
Oh, no, never mind. I didn't.
So if it was flipped around, you would just have to use a symmetric property at the end to flip it.
So the 1 can make it negative?
Yes. Because it's a negative 1. So you do a positive divide by a negative to get a negative 5. Because 1 minus 2 is negative 1. All right, so then any other questions on number 6? Okay, number 7. So I'm just going to go here. All right, so we're given G is equal to 2H and G plus H equals K, and that K is equal to M. So, okay. And so we're trying to prove that M is equal to 3H. So that means that we need to get an equation that only has M's and H's. So we know that G is equal to 2H. So I would take this 2H and put it in this middle one. And we also know that K is equal to M, so we can substitute that M in for that K up there. So then in step 4, right, so we're taking that middle equation, so that G is going to become a 2H plus another H is equal to M. Right, and then did you do another substitution after that? That's fine. I'm just doing it in one step.
And flipped it in my head there on that step, and I wrote it the opposite way. And I didn't write symmetric property or anything.
Okay.
Like I was just.
Yeah, technically you would need to do symmetric property, but that's okay. It's just practice stuff.
Just
So.
doing it. Wait, is that what it was?
No, not yet. So this is substitution. Yeah, so if you went ahead, because Kaylee, you said you just kept it as a K and then did another substitution and change, that's fine. Yeah, I just did it in one step. So if it's the same property like that, you can do it all in one step, or if it's easier for you to split it up and do substitution twice, that is also perfectly fine. And then we're going to then, so 2H plus 1H is 3H. So for that one, you're just simplifying. It's not the addition property because you have to add something to both sides. Yeah.
I never wrote anything, I just wrote like.
That's fine. If you just even left it blank, that's okay too. But technically what we're doing is simplifying. All right, so then yes, our last step, we need to switch it. So we need M equals 3H, and that would be the symmetric property. So for that one, we have AB equals 8A. And we have B plus D equals 20. So let's look at the first part. Oh, and we're trying to prove that D is equal to 12. So we're trying to solve our equation for D. So that means that we're going to have to, if we look at that first equation, right? We see that we have an A on both sides of it. So we can divide both sides by A to get rid of that A completely. So then if we divide those by... Did we?
Because you told us that.
Yeah, I know I helped some people with it yesterday, but that's all right. I'm also recording this for the people that aren't here so they can check their stuff too. So it's fine. It's all good. So then the A's cancel out. So that means in step 3, we're left with B equals 8. And that is the division property.
So the B equals D equals 20 is a part of it?
Huh? It's not a part of that step, no.
So it is part of the thing?
Yes.
Okay.
Right, and so now we can take that B equals 8 and we can plug it into our step 2. So then we have 8 plus D equals 20. And that is substitution. And then what do we need to do to solve it for D?
Subtract.
Yep, so minus 8 and minus 8, which then gives us D equals 12, which is what we were trying to get to, and that was our subtraction property. Right, so page 8, the first one. It didn't work. I went too fast. Alright, so then we have W plus 4 equals 7W minus 2. So that is given. And then step 2, we also have V is equal to W, which is also part of our given. So we're trying to prove that V is equal to 1. So we need to get an equation that only has the letter V in it. So how would we do that?
Destroy everything.
You change the W to a V.
Yep, so we're going to change the W to a V.
I didn't
Alright.
do that. I went the whole way through, and then at the end I got W equals 1, and then I substituted it.
Okay, that's perfectly fine. Right, so you can do it either way. So you can substitute at the beginning or you can solve it first. Did everybody solve it first? Did a lot of...
For 1 now.
Okay. All right, so then let's go ahead and work out that number 1 problem first. So what, did you guys move the W first?
I did not move the W. Yeah, I did.
So you like subtracted 7W?
Oh, I did. No, I got rid of the 4.
Okay. Well, you can do that in either order, and it should still make your steps about the same. So, Sam, this is going to look a little different in the order from what I did for you, but... All right, so then, why did I put it under the 4? Probably because Kate just said 4.
I did the 7.
Okay.
I knew it at the same time. I know I shared those stuff.
Yeah. All right, so then step 3 is going to give you negative 6W plus 4 equals negative 2. And we got that from doing the subtraction property.
Accidentally put instead of a D, I put an S, subtract.
Then how are you going to get 1?
Hold on. So then you're going to subtract the 4 from both sides, which gives you then negative 6W equals negative 6. So then that is also the subtraction property. All right, so yours might look a little different than mine if you went in a slightly different order. That's okay. Right, and then we're going to divide by that negative 6 to get the W by itself. So W equals 1. And we got that from division. All right, and then now we need to do substitution. Right, so we're going to substitute W in for V, or for V in for W, sorry. So then you have V equals 1. Go back, yep. So you could have done the substitution first and then worked the problem out. But yes, Dylan, I've had a sweet potato.
They're awful.
Oh, yeah.
All right. So on the last one, we have C plus D equals F. We have F equals K. And we have C equals D. And we're trying to prove that K is equal to 2C. So all right, so we need to make an equation that has just K and C. Because it's K equals 2C.
Yeah, but C equals D.
Right? So I would take this D and change it to a C from this. Right, so this here lets us change this to a C. Right. So let's go ahead. We're just going to break it up into different steps. So C plus C equals F. And we did that from substitution. That's fine. All right, Caitlin, where'd I lose you? All right, look. So C is equal to D.
Yes, but C is equal to D, so C changes to D.
No, D equals.
I mean, you could do that, and then you would have to change it back at the end. No, I mean, that's not incorrect. Like, you can do it that way, but then you have to change it back to C at the end because you're trying to prove. You've got to look at what you're trying to prove so that you want the C's. So you want to change the D to a C. All right, and so then we're going to substitute again. Right, we need to make the F into a K. So that one, we have C plus C equals K. Yeah, if you did it in one step, that's fine.
Then you add.
Right, then, yeah, you're going to simplify that left side. So we're going to add 1C plus 1C to get 2C.
And then you use the symmetric.
Yep, symmetric property, and that allows us to do what? Switch it.
So hard.
All right, and that's it. Any questions on those?